The basic idea of recovering heat from a data center to the district heating network is essentially just a basic one, that in a city like Stockholm, where we're currently doing this, there is a tremendous need for heating in buildings. It could be anything from heating for the purpose of keeping the climate in the house at the right level, or to produce hot tap water. And we're just trying to construct a model where the heat that would otherwise be wasted can be used for the purpose of meeting the needs of the people living in Stockholm. And in this kind of setting, we're solving a problem in both ends. We are moving something which is generally a problem for a data center, getting rid of the excess heat. We're taking it from those facilities and transporting it through the vast network of district heating pipes to the end users, which are the people living in Stockholm and the businesses in Stockholm. We are definitely trying to make the investment worthwhile, and we have some respect for the need to have fairly short payback time for data centers. The key thing to doing this is to maximize the synergies between the two sides of this. On the one hand, the heating market, and on the other hand, the cooling need of the data center. And secondly, to use capital smarter than it would otherwise be used. So on our side, we're saving capital cost by utilizing the capacity to produce heat in the data center that we would otherwise have to have in our system. And on the data center side, we are using the capacity that would otherwise be idle more effectively. So let me give you an example how this would save capital costs for the data center. One thing we're trying to integrate in this is that what is normally a capacity for redundant reserve cooling can actually be used in the wintertime to recover heat. So instead of just thinking of a cooling machine or a heat pump as something which is idle capacity, we're putting it at use in the winter. The second thing we're doing, which is a way to create a smarter system both for us and for the data center, is that we're integrating the production capacity in our large system. By doing so, you can bill for your future demand, but we'll put the capital at work from day one. So rather than just using the capital for a minor load that will grow into the costume over time, we'll use it as an integrated part of our system, and then eventually, as the data center grows into the costume, it will be a larger and larger fraction of the use that will be the data center itself. And both these things saves capital costs. So we're trying to do a business with a data center that creates value through both OPEX savings and CAPEX savings. And this generates a fairly short payback time, roughly 5 years.